Tony has two robots you've been helping him program, Sidekick and What a Driver. Sidekick can cook and clean, while What a Driver can, you guessed it, drive you around and take you places. But what if Sidekick could also drive, and What a Driver could whip up a meal? Sounds like a dream, right? Well, in Java, this can be achieved with a little help from interfaces. In this video, you'll explore how interfaces allow us to implement multiple inheritance in Java. But what exactly is an interface? An interface in Java is a type of class that's defined using the keyword interface instead of class. But there's a twist. Unlike classes, interfaces can only have abstract methods, which means these methods don't have any code inside them. Let's code an interface. Imagine you have an interface called fly. Instead of defining it like a regular class by writing class fly, open curly brace, close curly brace, you'd write interface fly, open curly brace, close curly brace. Simple as that. But something else needs to change here. You must change the interface name from fly to flyable. Now, why do you do this? It's all about Java's naming conventions. Using descriptive names and adding the suffix able when representing a capability or behavior is recommended. This helps make your code more understandable to other programmers who also use Java naming conventions. Here's something else to remember about interfaces. They can't have regular properties or instance fields. When you declare a field in an interface, it automatically becomes a constant that is public, static, and final, even without explicitly using those keywords. For example, if you declare a field in an interface as int max meters per hour equals 240, the field automatically becomes public, static, and final. In other words, a constant that can't be changed. Since fields in an interface are final constants, they must be assigned a value at the time of declaration. If not, the code will result in a compilation error. Inside an interface, all methods may only be declared and not implemented. You declare methods by putting a semicolon at the end and not curly braces after the method signature. At this point, you may be wondering how you implement interfaces. Let's find out. To use an interface in a class, you use the implements keyword after the class name, followed by the interface's name, and then the class's opening curly brace. This tells Java that your class will provide the actual code for the methods declared in the interface. If the class inherits from another class, the keyword implements should be written after the keyword extends and the name of the parent class. A class in Java can implement multiple interfaces. For example, a class could implement both flyable and walkable interfaces by separating them with commas. This is how you can give your robot both the ability to fly and walk. So far, so good. You've learned what an interface is and how to implement one or more interfaces. Now let's dig into some of the rules for implementing interfaces. Here's a key rule. Classes can only implement interfaces, not extend them. What does this mean? Remember that an interface contains only method declarations or abstract methods and not method definitions. When a class says it implements an interface, it is an agreement or contract that the class will define or give body to all the methods of an interface. Giving body or defining a method means adding curly braces after the signature of the method in the implementing class. Java doesn't require you to write any code inside the curly braces, but the method must include them to be considered implemented. If the implementing class does not fulfill the agreement of defining all the methods from the interface in the class, Java steps in with a penalty. It will mark the implementing class as abstract, which means you can't create objects from it. And if your class becomes abstract, you'll also need to add the keyword abstract before the class name. Enough about penalties. Let's learn more about interfaces, specifically inheritance. You saw earlier that a class cannot inherit or extend an interface using the extends keyword. However, one interface can inherit from another interface. If you implement an interface that inherits from another interface, you must implement methods from both the parent and child interfaces. For example, if Sonic Speed Flyable extends Flyable, a class implementing Sonic Speed Flyable must handle methods from both interfaces. In short, when a class implements an interface, it must implement all the methods in the inheritance chain of the interface or become abstract. Now, you might wonder, can you create objects of an interface? Yes, but not directly. You can only create an object of a class that implements the interface and assign it to a variable of the interface type. This variable can only call the methods defined in the interface. For example, if you have a class duck, which implements the interface flyable, you can always say flyable object equals new duck, open parenthesis, close parenthesis, semicolon. An object assigned to an interface variable can only access the methods defined in the interface, not those specific to the class. So if the duck class has a quack method, the flyable object wouldn't recognize it, since quack isn't part of the flyable interface. When you code this in IntelliJ, it will be flagged as an error, and if you try to compile it, you'll get an error message saying, cannot find symbol of method quack in type flyable in the variable flyable object. You also can't create an object of an interface directly using the new keyword, such as flyable object equals new flyable, open parenthesis, close parenthesis, semicolon. If you try, IntelliJ will flag it as an error, and running it will give you an error message saying, flyable is abstract, cannot be instantiated. This happens because interfaces contain abstract methods, meaning they're incomplete. If you could create an object of an interface, Java wouldn't know what to do when these incomplete methods are called. Makes sense, right? So why go through all this trouble? Well, because interfaces are powerful. They allow you to enforce the creation of certain methods across different classes. This can be incredibly useful when you need to ensure consistent functionality across various parts of your program. Later, you'll learn how interfaces work hand in hand with casting to create flexible and maintainable code. In this video, you learned what interfaces are, how to implement them, and some of the rules you need to follow when doing so. And there you have it. Interfaces in a nutshell. Whether adding cooking skills to your driving robot or teaching your flying robot to walk, interfaces in Java give you the flexibility to combine different abilities. So, if you have interfaces for cooking, driving, or flying, any robot can perform those actions by simply implementing the respective interface.